Hello guys, today we are going to discuss circuit analysis. So here in this circuit we have a diode. So we are going to solve this circuit and we are going to find the following terms. First we are going to find I, we are going to find V1, we are going to find V2, and we are going to find V0. Now so this circuit will look like this when we here is a plus 10 volt voltage E1 so which is connected to the ground. This one is a 5 volt voltage which is connected to the ground, so minus 5 volt E2. Now here is a V0 voltage. This is connected to the ground, so our circuit will look like this. Let's try to solve this circuit. Now our circuit will look like this. Now let's apply Kirchhoff voltage law. We are going to apply Kirchhoff voltage law. According to Kirchhoff voltage law, the sum of all the voltage inside a closed loop is equal to the sum of all the voltage drop inside a closed loop. So let's apply this phenomena. Here we have in this loop we have two voltage sources. One is E1 and other one is E2. So if we apply Kirchhoff voltage law, what will happen? E1 plus E2 is actually equal to I1. I current is flowing inside this loop, so voltage drop here in this circuit is I with R1 and I with R2, and VD, the voltage drop across a diode. Now when we simplify this equation, what will happen? We take I is a common from R1 and R2, and I E1 E2 VD Now what will happen? We take I as a common from R1 and R2, and E1 plus E2, and we move VD from right hand side to the left hand side. Now what will happen? Here E1 is 10 volt, E2 here in this case is 5 volt. Voltage drop is minus 0.7. Now resistance is across R1 is 4.7 K and 2.2 K. Now what will happen when we solve this? So actually equal to 6.9 K. When we use a calculator to solve this, it's actually equal to 2.07 milliampere. Now we found the first term, which is I. Now I is found here. In this case V1 and V2 can be easily find here in this case. So now so I here in this case is 2.7 milliampere cross 4.7 K. So which is equal to 9.73 volt. In the second case, which is equal to 4.5. So V2 is actually equal to 4.55 volt and V1 is actually equal to 9.3 volt. Now the last term we are going to find, which is now we are going to find V0, which is the last term here in this case. Now what will happen here, when we are going to find the V0, we will apply the Kirchhoff voltage law across the loop 2. So the sum of all the voltage here in this case is V0 plus E2, which is equal to V2. Now V0 is actually equal to V2 minus E2. Now V0 is actually equal to V2, which is here in this case we found is 4.5 volt minus E2, which is 5 volt. Now which is equal to minus 0.45 volt. So we found the following three element here in this circuit. First one is I, which is equal to 2.07 milliampere. V2, which is equal to 9.73 volt. V1, and V2, which is equal to 4.55 volt. And the last is V naught, which is actually equal to this one. So this in the overall lecture. So thank you for watching.